Okay, hi everyone, this is my first tutorial, more of a walkthrough actually, on how I created this project. We'll be working with the geometry nodes in Blender, and I'll also take you through the shader setup and compositing to achieve a similar result. So let's get started by building the base object first. We'll try to keep things simple, just create a cube and modify it as much as you like. Add some pebbles, and don't worry too much about keeping it all clean, it doesn't need to be perfect. Next, smooth out the shape and add bevel modifier to the edges. Finally, rotate the cube 90 degrees on the y-axis. This will make it easier later on when we rotate it along the x-axis. Now move the cube off the viewport and we'll dive into geometry nodes. Step 1. Creating the geometry nodes. Start by adding a plane. Then open Geometry Nodes Editor and create a new node setup. You can delete the group input node, we don't really need that. Add a curve line node and connect it to the group output. Make sure the line stretches horizontally across the x-axis with a length of around 16 meters. Next, add the resemble curve node and instance on points node. Drag the cube that we previously created into the editor and plug it into the instance on points node. Use the resemble curve node to adjust how many cubes appear along the line. Around 50 cubes works for me, but feel free to tweak it based on the size of your cube. Step 2. Edit control with an empty object. Now let's add an empty object to the scene. This will control the distance, which we'll use to affect the scale and rotation of the cubes. Drag the empty to the Geometry Nodes Editor and use its location as the starting point for the baseline. We'll calculate the distance using a geometry proximity node and feed that distance into the rotation input of the instance point node. At this point, you'll notice the rotation affects all the axes, but we only want to rotate along the x-axis. To fix this, use combine XYZ node and select only the x-axis. This is why we rotated the cube on the y-axis earlier. It ensures we are rotating only on one axis now. Step 3. Controlling rotation and scale. To make sure only certain cubes rotates, we'll use a map range node to control the distance value from the geometry proximity node. Adjust the value as needed. Then use a math node and set it to multiply to control the intensity of the effect. Now select these three nodes, duplicate them with Shift D. And connect them to the scale input of the instance endpoints. This time we'll only scale the cubes along the Y and Z axis. Tweak the map range values until you're happy with the result. Step 4. The animation setup. We're almost done with the geometry node setup, but let's first animate it. We'll animate the empty object by sliding it along the x-axis. Set the animation to 120 frames. Insert a keyframe at frame 1 for the empty X location. Then move to the frame 121 and set the X location to -8 meters, and then insert another keyframe. To make the animation steady, go to the curve editor by pressing Ctrl Tab on the timeline. Zoom in, select both keyframes, press Shift E, and then choose linear extrapolation. adjust your camera and test the animation. You'll notice it's not looping seamlessly yet, so let's fix that in the next step. Step 5. Seamless loop fix. Go back to the geometry nodes editor and we'll add 2 new empty objects using join geometry and a mesh line node. Use a vector math node to adjust the starting location. Now the loop should work properly. Step 6. Material and shading. Next, let's move on to the materials. First, create a material in shader editor. Then go back to the geometry nodes editor. And add a set material node at the end of the sequence. Select the material you just created, then head back to the shader editor. For the material, we'll combine 2 principal BSDF nodes, one for a primary color and the other for the metallic loop. I want each cube to have either the primary or metallic color, but the cubes that scale up should all have the primary color. For the primary material, I use subsurface scattering to give it translucent effect. And for the metallic material, I'll simply enable the metallic value and adjust the base color to get the right darkness. Step 7. Using the geoproximity for material control. To control where the materials are applied, we'll use the store name attribute node to store the distance value from geometry proximity node. Don't forget to name the attribute so we can reference it later in the shader editor. This distance value will range from 0 to 1, with 0 being the furthest point and 1 being the closest. To visualize it, think of 0 as black and 1 as white. If the colors look cramped, you can use a map range node to spread the values out more evenly. Go back to the shader editor. Use an attribute node and type in the stored attribute's name. Change type to instance, and now you can use this as the factor for both principal BSDF nodes. I also add some randomness using an object info. exciting? Well, usually my general approach is to start with the blackout scene, so I can focus solely on the lighting. For the lighting, I follow the 3-point lighting setup, starting with the backlight first, and then I add some fill light. My process is to ensure that each light looks good on its own, so you'll see me turning on one light at a time and tweaking around it. For the world lighting, I'm not using any HDRIs, just adding a smoky background with a principled volume shader. Step 9. Compositing setup. My go-to compositing setup includes 2 glare nodes, a vignette, a lens distortion node, and some color balancing. final thoughts. I also sometimes use the denoise node in the compositor, as it can work better than the one in the render setting sometimes. If the result is significantly better, I'll use it. Otherwise, I skip it. That's it. Thanks so much for sticking with me until the end. If you like to explore this project file yourself, I share it on my